The considered ion-dipole and ion-ion interactions relate to equilibrium conditions when the microscopic state of the system does not change with time. But the equilibrium in electrolyte solutions is always dynamic, averaged by time and volume. Particles of the solution, ions and solvent dipoles, all the time make chaotic movements, which are carried out by periodic jumps from one place to another. But on average, these particle movements are compensated, so that a directed microscopic transition of ions and dipoles does not occur under equilibrium conditions. If ionic equilibria are observed in the electrolyte solution, they also have a dynamic character. For example, a reaction. It proceeds in both directions, but the rates of the direct and reverse processes at equilibrium are the same, so that the average concentrations of ions and undissociated molecules in the solution remains constant. In the electrolyte solution, non-equilibrium phenomena can be caused by the following methods. A change in the concentration or rather activity of the solute in one part of the solution relative to the other without changing the chemical composition of the solution. The imposition of an electric field that will cause the directed movement of charged particles. A change in the composition of the solution with respect to the equilibrium concentration of substances possible for a given system. In the first method, the number of jumps of a given particle in the direction of decreasing its concentration is greater than the amount of this particle in the opposite direction. The result is a diffusion stream. The laws of ion diffusion are directly related to electrochemistry. Since a non-equilibrium process in the electrochemical system, for example, electrolysis in a solution, is accompanied by a change in the concentration of reacting substances near the surface of the electrode compared with the concentration of these substances in the volume of the solution. In the second method, the application of an electric field changes the probability of jumps of charged particle across the field and against the field. For cations, the number of jumps in the field exceeds the number of jumps against the field, and the opposite is observed for anions. Thus, as a result of applying an electric field, migration flows of cations and anions arise. The migration of ions, which forms the basis of the electrical conductivity of electrolytes, accompanies the work of electrochemical system and is also directly related to electrochemistry. In the third method, a change in the composition of the solution violates the ionic equilibrium and causes a chemical reaction, during which the ionic equilibrium is restored. Ionic reactions in electrolyte solutions are a special case of homogeneous chemical reaction and are studied mainly by chemical kinetics. A distinctive feature of many of them is their high speed in comparison with other processes in solutions.